I want to look at a bit more what's in the standards, but breaking it down to smaller sections. And I guess the first thing that I want to talk a bit about is probably what most people are focused on, and it seems to be almost the centerpiece of this edition of the wiring rules, and that is RCDs. So we've had a bit of conversation so far, we've mentioned some changes, but just as a summary, what has changed and why?
Yeah, I might just go a little bit of history in this. That edition there, the 1986 wiring rules, had one mention of current operated earth leakage circuit breakers, as they were called there, rather than residual current devices, which said you can use them, but they're considered supplementary, and everything was based around earthing and overcurrent protection. But there were voltage operated earth leakage circuit breakers, where you had to have a special wiring system of earthing your building and a separate earth electrode, and leakage current to earth would be detected by the voltage rise. That caused a bad reputation for earth leakage, because they could trip for a fault in a neighbour's place, and there was lots of problems. The current operated RCDs eliminated all those issues, but there was still it's earth leakage and it's a problem. When we introduced the 1991 edition, that was the first time that RCDs were actually mandated, and they were only mandated for socket outlets, just socket outlets, because in analysis we found that 87% of electrical fatalities would have been protected by having RCDs on socket outlets. So that was the first introduction in Australia. New Zealand didn't do it, and that it wasn't a joint standard at that time. And then each edition, we've gradually added more requirements. The next step was it was found that there were problems where people were drilling into wiring, so that the piece of wiring going from the switchboard to the socket outlet wasn't protected. So then it was final sub-circuits to be protected, but because of the concern with leakage currents in stoves, they were exempted. And in this edition, every final sub-circuit in household must be protected, and industrial and commercial up to 32 amps. A lot of commercial buildings were actually putting in RCDs because under section 1.6 you have a duty of care to provide an adequate installation, and a lot of consultants interpreted that as needing RCDs. Now there's no question, it's in section, in the part 2 section, and you must have RCDs. So it's become pretty universal, and New Zealand is sort of about where the old edition of this wiring rules are. They've still got exemptions for heating elements, but as Lindsay said, they have higher requirements with type A RCDs, whereas we have type AC.
And they also switch to neutral.
And it's double pole switching, yeah. Which we don't see any evidence of actually needing that. Yeah. Maybe for transportable homes and things like that, it's a different system, but for fixed wiring, there's no evidence of that.
Is there a reason why it's constantly evolving? Is it that we haven't been able to get it right, or is it that the technology keeps changing?
Well, one of the examples I gave was that if we'd mandated on all final sub-circuits in 1991, every stove would have caused the RCD to trip.
Fridge, freezer.
And fridge freezers, because they had heating elements to stop condensation and things like that. Now, the technology used for heating elements has improved, and they don't have leakage current, so they will work with RCDs. So now that that's changed, you can then go to mandate RCDs to protect stoves and refrigerators and freezers, and there are not problems. So, and there's plenty of experience there that it works. So you've got to keep the technology in step with each other. So the appliances have to reduce their leakage current so they're not going to trip with an RCD, and then you can mandate RCDs to use with those appliances and electrical equipment. But in industrial, there's still a lot of heating elements that do have leakage current, so it's not mandated for all industrial applications that have heating elements in them. So and they have to rely on secure earthing to get protection for those installations.
Has anyone raised any potential side effects to this most recent evolution of the RCD requirements?
There are concerns that if people bring an old stove into a new wiring installation, there'll be problems, and so there's going to be issues, and people will have to change, especially with heating elements. They will have to update to modern technology to be able to use it. That's possibly why New Zealand hasn't mandated it, because they have a strange quirk that your stove is not considered part of the installation. People take them with them when they buy a new house. They take their stove with them. So if they bring an old stove into a new house, if it had an RCD on it, it'd probably trip. So yeah. Whereas in Australia, if it's a new house, it's going to have a new stove, and that stove won't trip with an RCD, so therefore it can be applied.
We're thinking that probably by the end of this year we'll have significant comments if there are problems that we would carry into the revision. So I guess the proof of the pudding's in the eating. Everyone's applying it. But what I've found nationally, and I travel a damn lot around the country, most installers, most electricians are using RCBOs on everything anyway, only because they carry them in the van and they just go and put them on. So the ones that have been doing that haven't been seeing the problem with making those changes, but we may start to hear some rumblings. Yeah, there'll be May cases or June, we probably might. So, and if it does, well then that's up to us to take it into the revision.
And that's another thing with the technology, that the early adoption of RCDs often was one RCD to protect a whole house, and then you got cumulative leakage. Even a little bit of leakage into a smoothing iron added together can add up to a problem. With the development of RCBOs, which is integrated miniature circuit breaker and RCD into one single module wide, and cost coming down, that we had a stage where you had to protect power circuits with an RCD and lighting with a separate RCD, or mix, so that if an RCD failed, you didn't lose all your lights. But now it's generally on every single RCD, every single circuit you have an RCD, because the cost of RCDs has dropped. So, and when you get individual RCD for each circuit, the cumulative leakage current is not such an issue, and the proof is that they're reliable. I mean, I've had RCDs on every single final sub-circuit in my house for 20 years with zero problem, and I'm sure everyone else has got some experience.
Is there was a push from, I think it was master electricians, to say we should have an RCD on every circuit, every final sub-circuit. There was no safety improvement of us changing the rules. So there's still that exception for 3 circuits per RCD. If you've got more than one lighting circuit, you share it across RCDs for the very reason that Dennis was talking about. You want to lose lights to all parts of your house. So those exceptions still exist, but there's so many, because of cost of RCBOs, there's just so many electricians now applying that rule. Just put RCBOs on everything and not have to worry. That's how I've seen it.
All right, so we'll come over to you, Lindsay. So something you've written about previously for electrical connection, and that was the inclusion of AFDDs in high-risk areas. But given their, let's say, complicated history, how has the technology actually developed to avoid things like nuisance tripping?
Sure. So the technology's been around now for over 20 years. AFDDs, or AFCIs as they were called in North America, were first patented in about 1996. Since that time, IEC versions have also been developed, and the algorithms that are used in the controller have improved, which helps to discriminate between true arcing fault in the installation wiring as against typical normal arcing that you may see in home appliances, anything which has got a motor with brushes in it that gets sparking from the commutator. Typically with the earlier devices that may have been a problem for them, but these days the algorithms are a lot smarter and can do a much better job of operating quickly to isolate that circuit where there is actually arcing going on.
And are there any specific clauses in this edition of the wiring rules that I guess address the threat of arc fault?
Sure. So there's a new clause 2.9 which covers arc fault detection devices, and as we've already discussed, it has an Australian element and a New Zealand element to it. So in 2.9.6 is the Australian only requirements, and it's very clear that it's a good idea to consider using these devices in certain applications, but it's not a mandatory requirement. But in 2.9.7, which is the New Zealand requirements, they're very specific about where you must use an AFDD.
And then there's Appendix O as well. So what exactly is included?
So Appendix O gives you, it's an informative appendix that gives you a lot more information about how to select an RCD, where it should be installed, at what point in the installation wiring, what things you need to consider in terms of the rating of the device, the nature of the circuit, and also other things that you may have to think about, like over voltage protection for the AFDD itself. Obviously they contain sensitive electronic devices, so you just need to think a bit more about what you're doing with them.
What we thought originally was that we needed some information so people could understand what an arc fault detection device is from just the basics. I would consider down the track that appendix will come out and the requirement will be just like an RCD, we'll just define it and move on. So it was all just about providing more information.